Good morning, everybody. So today let us have the class on fermentation of classes of organic compounds, in continuation of the classes on mass spectrometry. So here we can discuss fermentation of classes like first one hydrocarbons. So let's see one first one saturated hydrocarbons, saturated hydrocarbons like say alkanes, okay. So how alkenes is undergo fermentation in the mass spectrometry. So here we can discuss in three ways. First one is open chain hydrocarbons, saturated hydrocarbons. Second one is uh, trans trans chain hydrocarbons, alkenes, and third one is cycloalkanes. Okay, cyclic compounds, cycloalkanes. So we can discuss in this the first one, saturated hydrocarbons. We can discuss three types: open chain hydrocarbons, branch chain hydrocarbons, and cycloalkanes. So let's study one by one. In the first case, open chain hydrocarbons, open chain alkanes. There is a breaking is a decrease of the loss of CH2 group, mostly say like M by Z about you need about 14 units. 14 units carbon 12 214 units are lost for every fractions. So for example, say in the case of, for example, the pentane, okay, let's say pentane CH3 CH2 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 CH3. So let's say this is pentane. Okay, so after bombardment of this one with a high energy electrons, so they give a molecular ion, this one molecular ion M plus 1, okay, M plus molecular ion is given. So let's say this is a mass M by Z value is about, say this is about 72, okay, same as the molecular mass of the pentane. So this is a saturated open chain compound. I'm giving one example, okay. So here loss here, CH3 loss, then we get loss, this one's 15, then this is 2 ethyl group, then again profile like this, so loss like this, okay. So you get so many fractions are coming up. So the mass, this one, so I'll give here 50 minus 50, then this C2H5 is minus 29, C2H5, then C3H7 minus 43, then minus 57, like that. So you get many fermentation can undergo. So I show you how fermentation goes like this. So for open chain alkane, okay. So we have say alkane CH3, CH2, 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 CH3. Okay. So after bombardment, it gives molecular ion M by Z is 72. Is same as the molecular mass of the and propane and pentane. And then I go many fermentation again, CH3 positive charge, then here, then you have C2H5 ethyl cation, then you can go C3H7 and C4H9 is positive charge, okay, C4H9, then C5H11, C5H11, okay. And plus this IC cation, or another one is C molecular mass is 71, and M by Z value is 71, and M by Z is, this is 42, 51, 57, and this is M by Z 43, M by Z, then this is 29, M by Z 15. So normally there are generally decreases of CH2 group. 14 units are decreasing from here, decreasing 14, 14, 14, like this. Okay, so it can show that we can say that the compound is saturated hydrocarbon in the fermentation takes place with CH2 fermentation. Okay, it's 14 units. So generally they can have alkyl group. They have And these are alkyl twice n plus 1 alkyl carbocation they have. Okay, generally saturated hydrocarbons lost like this. And it can branch ends. Then the next is about a branch end. Hydrocarbons can have branching. So here, as we have discussed most of fermentation in the earlier classes, we have discussed about the most of fermentation. So fermentation takes place adjacent to the branching point. So here let us say one example, okay, for branch end, branch and hydrocarbons, branch and hydrocarbons. Okay, here say one example we take say, methyl CH3, 2 methyl CH2, CH2, 1, 2, 3, 4, CH3, okay, CH3, 2 methyl pentane, okay, 2 methyl pentane. Here we can have first one, so after bombardment with high electron energy, we got a molecular peak, this M plus ion. Then you can undergo fermentation, many fermentations can go. So branching point here, largest alkyl group loss to get a more fraction. So here another one, CH3, CH3, CH3. Fermentation takes place at a branching point. Okay, here this will give M by Z, and then 57 here, C9 is 7. Okay, then you can lose. This also can be lost here. This can be lost again. This can be lost as this one as a positive charge CH2, CH2, CH3. The positive charge it can be delocalized as one proton can, so you can have this stabilized as carbocation as secondary carbocation. So you can get M by Z 43. Okay, C3H7 43. Okay, 43. So here like this. Then again it can be broken down here also. You can have another fragment, and like this many fragments you can come. Okay, so this way you can have, or you can go this way. Then you can have another fragmentation. Say CH3, CH3. Let's say this one is broken down. This fragmentation, either one of them is broken down. The positive charge in CH2, and then you can have this one can be lost down CH2, CH3. Another example, I'm giving one example. Okay. CH2, CH2, CH3. Broken down here, CH2, CH2, 1, 2, and CH3. So here you can have another M by Z value. So in this way, many fermentation can give. So here many peaks will come. So here, what I want to tell is in the case of branch and hydrocarbons, fermentation takes place generally at the branching point. Then let's talk about cyclic compounds, cycloalkanes. In the case cycloalkanes also, if you have a suppose if you have a branching point, so like something like this, then after bombardment you can have molecular peak. So let's say this is M by Z 128. You can consider this compound at a branch end. Okay, in cyclic alkanes, cycloalkanes with a branching one. So here branching is also broken down here a branching point, so you can give either CH3, CH2, CH3, CH2, CH2. This is the radical, and this one is the positive charge. Okay, this one also can undergo again. This one also again bombardment will give another fragmentations. So like this, so you can give another fragmentation like this. Okay, so you can give go another fragment like this. So positive charge, negative charge, or you can write plus CH2 double bond CH2. Okay, this one you can go like this one can go this one and this one, this one. So here and this also like this. So you can write this one equivalent, like you can write this way also. Okay, this one is almost same as this one. So you can write. So you can have many M by Z below. So what I want to say in the case of cyclic compounds, cycloalkanes, the fermentation take place if there is a branching one, and then this again undergo fermentations like this. So this is about saturated hydrocarbons. So I'm giving about fermentation of saturated hydrocarbons. Now let's come to second one, unsaturated hydrocarbons. Okay, for unsaturated hydrocarbons, second one is unsaturated unsaturated hydrocarbons. Second one is unsaturated hydrocarbons, so you can say alkenes. For alkenes, fermentation is almost similar, but here there is one important thing is that there is a cleavage of the beta bond allylic position. Here one important is cleavage takes place. Cleavage takes place at the allylic position. At the allylic position means at the beta carbon bond. It is at the beta bond. Okay, beta bond. So this one shows a high intense peak. So cleavage at the, for example, say let us say this one alkane CH2, okay, let's say R. Okay, so this is one alkane having an alpha and beta like that. So alpha bond, this is beta bond. Okay, so here in this case cleavage of the beta bond takes place. So now let us have after bombardment with high energy electrons, so it gets a molecular ion peak M plus. Okay, so it lost, this one is lost like this, so it is lost this way, then you can get cleavage takes place, CH2 double bond CH2 CH2. So this is the one R radical. So this cleavage will give high electron and by the value it gives a high intense peak. So this one peak. So what I want to say is that one of the most intense peak in the case of alkenes is that allylic cleavage takes place in the allylic position. Here cleavage takes place in the allylic position. That means the cleavage at the beta bond takes place. Okay. So here most of the fermentation monoalkyl often occurs like earlier cases by branching point or others also can take place. And the case if it has a long chain, if the R is a long chain, then if suppose there is a gamma hydrogen in this case, then you can, like earlier cases, if there is a gamma hydrogen, then you undergo magnetic rearrangement, just like CH2, KH, CH2, 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 okay, C, H double bond, CH R, okay, this is CH R, this is R, okay. So let's say a long chain has unsaturated hydrocarbon alkenes. So here, like magnetic rearrangement, you cannot go magnetic rearrangement. So here gamma hydrogen here, alpha, beta, gamma hydrogen here. So after bombardment this with high energy electrons, you got a molecular ion, and so then transfer of hydrogen atom takes place, and like this cleavage of the alpha beta bond takes place. So you got in this case magnetic rearrangement takes place. Okay, so here CH2 double bond CH2, yes, CH double bond CH2 plus CHR, then here under hydrogen comes CH2 and CH double bond this CH2. Okay, so like this is got like this. Okay, double bond here, and then here's my one hydrogen transfer here, so it goes like this. So by that value, this one gives high intense, mostly in cases, some cases you can have base peak, it shows base peak. So this type of magnetic rearrangement can also magnetic rearrangement can also be found in unsaturated rearrangement can also be found in unsaturated hydrocarbons, I mean alkenes by having long chain. So one, this is about the, so branching also same case like earlier one. So you mostly here in this case we found peaks due to the Cn is twice n minus 1. Okay, twice n minus 1 peaks are obtained in this case. In the alkenes, mostly peaks are obtained from this one. Then in the case of cycloalkenes, similarly you can have discussed cycloalkenes also. Here cycloalkenes, so generally like earlier I have shown this, they throw this other reaction step. For example, I am giving cycloalkenes. Okay. So after one example I am giving. So with this branch, and the branching can be prolonged down, branching can be, with this branch like this, and branching can take place. So let us discuss simple one. Okay. So let's say R here. So now after bombardment with high energy electrons, so we got a molecular ion first, this molecular peak, then lost this, so one loss here, so you can give one here, goes. So yeah, one electron movement takes place here, one electron movement takes place, and then here double bond here, and then here double bond. So one uh, one electron movement takes place here. So you got double bond here, double bond here. So here got plus. Here is R double bond. This is CH2. Okay. So like this. So here you got a high density M by Z, or say M by Z 54. Okay. So in this case, these retro digital reactions. So retro digital reactions, digital reactions. So in the case of cyclic compound, cycloalkenes, so here you can have this type of rearrangement take place. So this is about the, so we can discuss McLeod rearrangement can take place also, and this retro-digital reaction also take place in cyclic compound. So here, similarly we have long chain here. Suppose we have long chains here like this, then see gamma hydrogen here, alpha, beta, gamma hydrogen here, then migration takes place. The migration takes place like earlier cases. Okay, so here also McLeod rearrangement can take place if there is long chain. So what I'm telling that in the case of unsaturated hydrocarbons, so fermentation can undergo with this cleavage with alpha cleavage, allylic cleavage takes place, and then that is the beta bond takes place, and they undergo this McLeod rearrangement as well as electrodistributed reactions. So these are about the unsaturated hydrocarbons. Now let's come to third one. Let's come to aromatic hydrocarbons. Okay, aromatic hydrocarbons. So let's have third one is aromatic hydrocarbons. So it's a simple one. The benzene is benzene simple benzene. So you have benzene one. So after bombardment with high energy electrons, we got this molecular ion. We have by that value is 78 C6. Okay, C6 I6 C6 I6. Then we lost one hydrogen radical, so it gives one. So let's say this is positive charge here, positive charge here, positive charge. So now lost one hydrogen here, so others are here. So here M by Z is one loss, which comes to 77. This is phenyl cation. You can say phenyl cation. So this one can undergo this type of rearrangement. So okay, this you can have this one four-member ring. So you can have this the positive charge will be here, the hydrogen here, hydrogen here, one positive charge. So you can have this called M by Z 51 C4H3. Okay, C4H3 positive charge. Okay, so like this we can have many. You can have many also fermentation. You can try this C3H3, yeah, M by Z 39. Another one C4H5 C4H5 M by Z 53. Okay, 48 plus 5 53. So this in benzene you can find this one. You can try this fermentation also. So simple, I'm repeating again, simple benzene molecule can undergo fermentations to give this type of ferment ions. Okay, so if you have, let's say, this branching point, if benzene can also have branching point, you can take branching point. So let us see one. Okay, let's see the branching point. See one example, say toluene. Let us have toluene. Okay, one example. So let us have this CH3. Okay, after bombardment, you will get with high energy electron. We got a M plus. What is the M by Z value is 92. Okay, so after you can go liquid like this, minus CH3 radical. So you can give benzene. Okay, this benzene you can get benzene get positive charge. So here M by Z 57. 77, okay, 92, lost this one, and 92 minus 15, 15 minus 15 will give this one, okay, after picking this one. Then you can undergo loss one proton here, so here minus radical, one hydrogen radical, so from here, then you got this CH2 positive charge, okay, so here, like this. Then this benzylium cation, benzylium cation, benzylium cation. So you can undergo many rearrangements. So you can have this resonance structures. This one is less stable. So you can have resonance structures. So here, so you can form many resonance structures here like this. So expand the ring. So you can have 7 budding now. So it can expand. Most of this undergo all around. So you got propylium cation, propylium as earlier cases, propylium cation. This is very stable. Okay, so M by J value is, this one is 91. From 92 lost one hydrogen radical, so it becomes 91. So it's a very stable one. This also can lose one. From here you can have lost this CH3, CH triple bond CH. This one lost. This is lost. Okay, this acetylene molecule is lost. Then you can have another one, pi membrane here. So here positive charge, and this is M by Z 65. Then you can say C5 H5 carbocation. This one is C7 H7 carbocation. Okay, so this way, this is one of the most peaks observed in the. These are very intense. This is the best. This one is propylium cation is the best peak, and other ones are high intense. This is also high intense, and this is less. This less. So benzene can have another fermentation, so on. So this is about fermentation due to the toluene. Okay. So let's see another branching one. So showing the Maillard-Fortin rearrangement. So benzene can have. You can show Maillard-Fortin rearrangement. So for example, say let's say benzene link here, link with a longer one. Let's say alpha, beta, gamma. Hydrogen here. This is one CH3 here. Okay. So here this compound having branch chain. So you can have after bombardment with high energy electrons, so we can have molecular ion M plus, and this is about one. Let's say M by Z. The molecular is about around, this is 134. Okay, M by Z 134 after bombardment with high energy electron. So you can have broken down here. So you can give benzene plus, so M by Z 77. After breaking down, this is goes at radical, and this can go fermentation. So you can go like earlier case, Maillard-Fortin rearrangement can take place here also. So also here Maillard-Fortin rearrangement. Here migration takes place like this. So longer chain. So you can have a fragment ions. This is fragment ions CH2 here, and this CH2 here, and this hydrogen here. One hydrogen already here, hydrogen here. Okay, this is you can say positive charge. Okay, molecular ion like this. One hydrogen migration due to the Maillard-Fortin rearrangement. So the plus lost this CH2 double bond CH3 is lost. Okay. This is nuclear molecule is lost. So methyl, this is so yeah. See about M by Z 92. Okay, 92. Lost this one. So you can this can, like earlier case, it can have many cation. You can have another, this one come, and this one come, cation come, and then can have many other cases like this, propylium ion, and like this. Okay, so on the other cases. So aromatic hydrocarbons, I'm repeating again, aromatic hydrocarbons can undergo fermentation at a branching point, as well as if there is longer chain, then you can have Maillard-Fortin rearrangement. Even simple benzene and toluene can also undergo fermentation to give this molecular ions. So you can draw this peak, molecular ion peak, mostly generally 91, and this can lose one hydrogen minus this one. Then you can have this one CH2 positive, and this one like other gases like this. Then you can have propylium ion like this, so on. Okay, so propylium ion, this is 91 M by Z 91. So that like this, so many. You just give the high base peak, give high base peak. 91 should be the high base, 92, 91, and 65 prime membrane, and 65, and so on. So now, thirdly, let's come to fourth one. Okay, another fourth one, fermentation of the classes of organic compounds. So in the fourth cases, you can combine all those other functional groups or other compounds. So like fission 2, the fourth one, fermentation at the fission position at the fission alpha to a carbon atom, alpha to a carbon atom, carbon atom, or substituted with heteroatom, substituted with a heteroatom. So here you can discuss all the other functional compounds, what heteroatom. So fission alpha to a carbon substituted with a so like this. Okay, let's say R, okay, R1, R2, R3. Okay, let's say heteroatom here, X heteroatom, or let's say so hydrogen. Okay, X is or a R ketone, or R, or let's say R. So let's discuss. X can be oxygen, or it can be then R can be hydrogen. Then we have alcohol. Here X is O, R is alkyl. Then we have ether, alkyl. Then we have ether, and S can be say nitrogen, like nitrogen. Then we have R can be hydrogen. You can apply this one to NH. And then we have amines. Okay, R can be hydrogen, R can be hydrogen or alkyl. Then we have amines. Then S can be also sulfur, like R is equal to hydrogen, thiols, and then X equal to sulfur, R is equal to alkyl, and thioether, like this. So many things. So we can discuss this thing in a group, together. Okay. So here our fission takes place in the alpha to the alpha position to the this one, the heteroatom. So the heteroatom. This means either here or here, alpha bond. So let's come to the. Okay, let's discuss this one. Okay, let's say this one. Let's say OH. We're going to discuss OH, alcohol. Okay. Let's discuss alcohol. First one. So after bombardment, with high energy electrons, so we have R, R1, R2, R3, O, then H. After bombardment, we have one electron is knocked out from here, so you got this one molecular ion. Then can fermentation takes place alpha to the carbon atom, the alpha to here. So here goes one, another one come here, another one come here. So it gives R2, C, R3, double bond OH, okay, positive charge, then like this. So this fermentation is very common here. So I'm giving one example for alcohol. And similarly, in the case of ether also, it is ether, then R1, R2, R3. Okay, so plus R1 it becomes the radical. Okay, radical. So here you can have any substitution you can undergo, but I'm keeping here R1 only. You can keep R2 also, can keep R3 also, can keep, or sulfur fission really takes place at the alpha fission, the alpha position, alpha carbon atom. So here larger group of the alkyl larger group will be clipped. It is preferred one as compared to the smaller one. So I'm here R1 is greater than R1 is greater than R2 greater than R3 in the alkyl group are greater than. So that's why gives bigger one is cliff. So here similarly we can have in the ether also. So let's say R. Okay, this is ether. This is ether. So the ether also cliffs after bombardment with high energy electrons. ether gives one electron is knocked out, so like this. So similarly, in similar case in the alcohol, so here also loss, this is keep a double bond here, so you can have R2 and R3 double bond O R. Okay, here positive charge. So this is M by Z. This is M by Z value. So the very high intense peak. Okay, this value, this compound goes. So in the cases of heterocyclic, hetero compounds with a carbon link with a carbon atom, then fission takes place, cleavage takes place, alpha to the carbon substitute with the heteroatom. So we have heteroatom oxygen here. Similarly, in the case of amine also, let us see the amines. Amines also another heteroatom nitrogen. So we have discussed oxygen. Now, similarly here also, let us say R, this is let's say CH2, NH2. Okay. So after bombardment, this we have after bombardment with high energy electrons, so you can have this like this. Okay. So here R is the longer chain, bigger fraction. So bigger groups. So loss like this, loss and this one. So we got a CH2 double bond and H2 positive charge here, ammonium radical. So this gives another one, and R is plus, R is radical is lost. So here you can have this also as a isonance hydrate carbocation. You can get also NH2 like this. So this is a M by Z value we can have. So this also gives high intense value, best peak. So yeah, I'm giving one. R can be many types. So this you can have this one. You can get like this peak is a very intense one. Okay. Similarly, we have one R. You can substitute here also. If substitute here, say bigger one, say R1 CH3, then you can have another CH3 here. So this way. Example. I'm giving one example. Suppose let's say one example here. Say the ethyl group, ethyl or propyl group, CH ethyl group here, then NH2. Let's say after bombardment with electron, high energy electron, you got this M plus, then you can lose. Similarly, you can lose this propyl will lose. Propyl groups will be lost like this. Cleavage takes place. So you got CH, Me, number one NH2. Okay, so you get another this peak shows a very high intense plus PR radical, okay, propyl radical. So this value shows a very high intense peak. So like this, so you can remember that 44, so very high intense peak. So what I want to say is for heteroatom, if there is a heteroatom adjacent to the carbon, link with the carbon, then the fission takes the alpha position like this. R can grow like this. It's sulfur also, thiol, thioether. This also can go similarly, all like just like alcohol, thioether, and thioalcohol. But in the case of fission to alpha carbon compounds, let's say carbonic compounds, say as the aldehydes or R1, R2, okay. For carbonic compounds, fission to alpha to a carbon group, fission alpha to a carbonic group. So here, after bombardment with high energy electrons, so we can have, after bombardment, we can have this one, okay, M plus ion, molecular ion peak. So we can lose this, R1 is greater than R2, then larger alkyl group, then you can like earlier cases, so you can have this one. So you can have R2 C triple bond O positive charge like this. So it can be this carbon can cation form, carbon cation can form or positive, okay. So like this. So here in the case of carbon group, fission alpha 2, fission alpha 2 carbonyl group takes place here. In the case of carbon compound hydrogen, then R group will go aldehyde. If it is aldehyde, then R2 will be R2 is equal to hydrogen. If it is aldehyde, and then R2 is equal to alkyl or aryl, then this should be ketone. Okay, aryl or alkyl and ketone. So here in the fermentation will give in the ladder like this to fission to alpha position. So it gives like this. Okay, so they have shown a high intense molecular ion, fragment ion. So this is about the fermentation of classes of organic compounds to the classes up to this I have discussed. So I will summarize about all of today's classes. So we have discussed first one is fermentation the alkanes, saturated hydrocarbons, alkanes. Alkanes can get we can discuss in three ways. First one is open chain, then second one is branch chain, and third one is cycloalkanes. From open chain, you can have a units of CH2 units are lost, 14 units are lost for every fraction, and then the branching we have branch mostly by value intense at the fermentation at the branching adjacent to the branching point. So here also in the case here also the largest alkyl groups are lost. If it is lost is preferred to cleave. So we got like earlier we had discussed. Then we get cycloalkanes also can undergo fermentation. Then second one is these are unsaturated hydrocarbons, alkenes. Alkenes generally take place as a allylic position in the cleavage at the allylic position. So alpha this beta carbon bond, then the bond, then you get the high dense molecular fragment ions. So these pictures are very high in the case of alkenes. If the alkenes has long chain, then undergo magnetic rearrangement, double rearrangement. So it also gives intense peak due to the magnetic rearrangement fragmentation. Then we have cycloalkenes also. You can have heterodyna믹 reactions, or you can have also magnetic also with a longer chains than like this. We have discussed this thing, okay. And third one is aromatic hydrocarbons. Aromatic hydrocarbons basically can undergo fermentation to give many fragment ions, and maybe toluene also can give fragment ions. And in the case of toluene, this molecular ion peak is very less as compared to the loss of tropylium ion. Tropylium ion gives the best peak, very high, M by Z 91, and then undergo loss 65, C5, H5 also very high peak, high intense peak. So this I have discussed already, okay. And lastly, this fission alpha to carbon heteroatom. If the carbon is linked with a heteroatom like sulfur, oxygen, nitrogen, and carbon, like this, okay. Then we have this fermentation which at the alpha position, you high Gibbs. They can also undergo magnetic rearrangement like earlier cases. Suppose in the case of carbonic compounds, they can undergo magnetic rearrangement. If it has, suppose carbonic compounds have longer chains, then can undergo, say for example, in the case of like this, alpha, beta, gamma. This also have gamma hydrogen here. Alpha, beta, gamma, okay, gamma hydrogen, C hydrogen here, CH2. Then can migration takes place, can get migration. Earlier we have discussed this thing, okay. Okay, carbonic compounds also can undergo magnetic rearrangement if they have longer chain or gamma having gamma hydrogen. So like this. So we have discussed this thing. So today we'll wind up this one. So I think mass spectrometry is mostly pleased about your syllabus, okay.